This is definitely a higher level thinking question because I have two logarithms that have different bases. So I don't want to exponentiate like this. It helps on the left, but then we're stuck on the right. I can't exponentiate with an 8. The right side's okay, but the left, we have a problem. So we have to exponentiate both sides with the same thing that will work out. We're thinking about a 4 and an 8, and we want to come up with a number that is both a power of 4 and a power of 8. For example, 4 cubed is 64, and 8 squared is 64. 64 is a power of both 4 and 8. So I'm going to exponentiate both sides with a 64. How does that help us? Because, next step, I'll rewrite 64 as 4 cubed, and the 3 becomes a coefficient on the already existing exponent. I'll rewrite 64 on this side as 8 squared. The 2 becomes a coefficient on the already existing exponent. Not quite there. These coefficients are in the way of using the inverse property. So now I have to use my power property to get those exponents out, those coefficients out of the way. Now I have nothing in the way of using the inverse property. So we have x cubed equals the entire 2x squared. 2 squared is 4. This is a polynomial equation, and we learned once a while back that we would set this equal to 0, use a GCF, set both factors equal to 0. X squared equals 0. Take the square root of both sides. X minus 4 equals 0. And we just have to plug those in to check for extraneous solutions. The 0 is a problem because I cannot take the log of 0. The 4 is okay.